Okay, so the common denominators, we're actually going to start with one that already has a common denominator, okay, just to show you what you would do and without that first step. Okay, so the first thing you want to do always, well, this already has a common denominator, so we're going to put them together as one fraction, and then you can do the same thing, see if they cancel. So how would we write that? We write it as one big fraction. We've got the denominator is 3 onto x minus 1. Now I set it up on purpose with a minus because people mess that up. So if you remember back when we did this section, whatever's in between has to apply to everything on this second fraction. So on top, on the numerator, we have x squared plus 2x. There's nothing to do to that bracket. But this one, that minus has to apply, minus x minus 2. So collect like terms. There's only one x squared. There's no other x squared, so just x squared. There's a 2x minus x. So just x. And then a minus 2. And we may be done at this point if the top doesn't factor. But the top might factor because it does have an x squared, so we would try that. So if we try to factor the top, two numbers that multiply to give 2, 2 and 1. And we want them to add or subtract, I guess, to give a positive 1. So that way, 2 minus 1 is 1. So that does have a common factor that we can cancel. What would be the restriction? X cannot equal 1. Cancel that out. So x plus 2 over 3, semicolon, x cannot equal 1. And someone asked if you have to do the restriction, and I said no, unless I ask, but I always ask, so. Yeah, I forgot to mention that part. No, but yes. Sounds like a parent, doesn't it? All right. Doesn't that look fun? Okay, so there's a hard way and an easy way. You want the easy way. So let's forget about this question for a second. You've got it written down. We're going to go off to the side. We're coming right back to it. But I'm just going to do it with numbers first to show you the hard way and easy way and what the difference is that we're going to do, okay? So let's say, for example, we have let's say 2 over 27 plus 1 over 18. Okay. So that one, without a calculator, is not very nice. Do you agree? But what is the lowest common denominator? So do we multiply 27 times 18 and use that as the denominator? You could. But it's not necessarily the lowest, and then the number's quite big. How could we find the lowest common denominator of these two without using that huge number? What do we do? Factor 27. So 27 is what? 9 times 3. and 18 is 9 times 2. They both already have a 9 in the denominator. So we don't need to put that 9 by multiplying this by 18 and this by 27. We're putting that 9 in twice. 9 times 9 is 81, so it's going to have a factor of 81 instead of just 9. Okay, you're making it bigger. What would be the common denominator? Look at these. To make the bottom the same, don't think about what it works out to be, but to make the bottom the same, we would need a 9 on both, which we already have. What else do we need? A 2 on both. Because this one has a 2, that one would need a 2. And then what would this one need? A 3, because the first one has a 3. So we would actually multiply this first one by 2. Do you agree? Yeah. So whatever 9 times 3 times 2 is, it doesn't even matter what the answer is. That would be a common denominator that we could do by multiplying this one by 3. Does that make sense? So if you look at what factors you have before you start, in this question up here, you are never going to just take this big polynomial and multiply it on top and bottom here, and this one on top and bottom here. You're going to end up with cubes or fourth powers that we're not using long division to solve, so that is not going to work for you because you won't be able to go further. I mean, you could go back and do synthetic division or long division that you did learn in high school to finish the question, but we're not doing it here, so there is a better way. Okay? So now what do we have here? 4 over, I don't even care, 9 times 3 times 2. I know what that works out to be, but I'm not going to write it, okay? I don't want to think that hard. This is one fraction, and what's on top? If I leave the bottom factored, I would see right now at this stage whether something cancels. Does something cancel? No, because that's a 7, and there's no 7. So nothing cancels, so I could just work it out. What's 9 times 3 times 2? Here I would do this as, it's 54, yeah. I would do it as 6 times 9. And we are confident that that's reduced as far as we can go because we already saw that this there's no common factor in top and bottom that can cancel. Okay, so what did we do here? We looked at the factors to decide what needed to be on bottom of each. That's what we're going to do up here. So we're going to go back to that question and factor the denominator. Two numbers that multiply to give 8. 4 and 2. Do they subtract to give 2? Yeah. We need a plus 4 and a minus 2. 4 minus 2 is positive 2. What about the top? Does that factor? Yeah. Yeah. 12. 3 and 4. Both plus, to add to give 7. Okay. All right, so we've got it both factored. Now take a look at what we have. What do you think the next step would be in this particular question? Yeah, the first fraction has a common factor that we could cancel and make it smaller before we do the common denominator. You just need to keep track of that condition for later, because you need to write that down at the end anytime you cross off something with an X in it. Okay. All right, so I'm going to rewrite this. Now, what would be the common denominator? X plus 3, X plus 4.
Can X not be equal to negative 2?
Oh, 2, thank you. Right, this one has both of those factors. This has one of them, the x plus 4, so we just need to put the x plus 3 with this one. So here, if we multiply this top and bottom by x plus 3, then we have the same denominator as the other fraction. Make sense? So you're doing these nice and slow. What do we do now that the bottom looks the same? We write it as one big fraction. Remember, they're multiplied, so it doesn't matter the order they're in, it's the same number. On the top, we've got 2 onto x plus 3 plus 1. Does that x plus 3 cancel? No. That's why I asked, because some people would cancel that. Why does it not cancel? Right, the 1 doesn't have an x plus 3. There's a plus 1 at the end. That's like we were saying before, if you have 2x over, or 2x plus 1 over 2x, the 2x's do not cancel because that 2x is not multiplied on top, there's a 1 added to it. Right? So this is already as simple as it goes. So they don't cancel. What you do, though, is work out the top. So 2x plus 6 plus 1. Which is what? 2x plus 7. Does that factor? No? And our restriction from canceling out that 2 at the very beginning of the question. So we have our answer, 2x plus 7 over, and you could multiply that out if you wanted to, but it's better to leave the denominator factored. Okay?
So because the x plus 3 and the x plus 4 are still there, you don't have to say...
Right, because they were in the beginning, and they're still in the end, so we don't need to state that restriction because it still holds. At the beginning, if we tried to plug a 2 into this, we would have this fraction with a 0 on the bottom, and the whole thing wouldn't exist. So the start of this question, it's understood that any numbers that don't work are not part of it. The numbers that don't work are -3, -4, and 2. But the -3 and -4 still don't work, so we don't need to worry about it. It didn't disappear somewhere in between. Right, you could say it. Right, but it doesn't matter. Yeah. Because it's still there. Okay, so the last example for today. Okay, so we're going to factor the 2 bottoms, the denominator. So 30. Multiply to 30, add to 11. 6 times 5. Both plus. They add to 11, they multiply to 30. 20. 4 and 5. If you can't think that quick, you write it down. You have to practice these later anyway. But we did the factoring part already, so there's nothing new in that part. Now, do they have the same denominator? No, we knew that before. The polynomials weren't the same. But do they have something in common? They both have an x plus 5. So just like that numerical question I did earlier that both had a 9, we don't want to multiply by that because it's already on the bottom of both. So we want to keep that 5. What do we need to multiply the first one by? X plus 4, the one that's missing. And the second one, x plus 6, the one that's missing. Now they're both the same. Okay, we have the same 3 factors. We can write that as one big fraction in whatever order you want them to be. I'm going to put them in numerical order. Put the top all together with that minus sign in between. We have no restriction yet. We didn't cancel anything out yet. Now, what do? Once you get it to be one fraction, you work out the top. Leave the bottom alone because it's already factored. Work out the top and then see if whatever you end up with factors. So here we have x times x, x squared plus 4x, minus 5x, minus 30. So, plus 4 minus 5. A lot of writing. Okay, does the top factor? Yeah, 5 and 6. 5 and 6 multiplied is 30, and to add to negative 1, or subtract, there we go. Okay. Now we've gone from two separate fractions, put them together, common denominator, factored both the top and the bottom, and does anything cancel? X plus 5. Does the x minus 6? No. And the restriction? Yeah, what makes that 0? The one we crossed off would be a negative 5, so x cannot be negative 5. So you can do that whole section now.